Okay, so now section 7.2, ellipses and circles. I'm going to be talking about the eccentricity. Okay, so for ellipses, either, in this form where the x is elongated horizontally or where the y is elongated vertically, the ellipse is elongated vertically. That's what the a square is here, and this is where the a square is over here. And then where c squared equals to a squared minus b squared because of the Pythagorean relationship, that it used to be a squared equals b squared plus c squared. And so when you get the c squared is equals to a squared minus b squared because it comes this way. So the eccentricity, they're going to ask you, what's the eccentricity of the ellipse? And the eccentricity is how much enlarged, has been happening, either vertically or horizontally. Well, you can measure the eccentricity by getting the c divided by the a. So if c divided by a, see, this is almost the same length as the length of a. If c divided by a, when you divide it, well, it's almost a 1, and that's why it's this. And for the second circle is c over the a, well, that's 0.71. C, when it's very small over here, and this is super huge, well, that's 0.32. And if the eccentricity, if a is the same thing as b, and that's the same thing as the radius, well, then we're talking about eccentricity is 0 because it's going to be a circle. Okay, so if a is the same thing as b, and that is basically the radius, well, that's just a circle. Okay, so we're talking about eccentricity. Now, let's go over one problem. Questions about how to get the eccentricity. So it's c divided by a, and that gives you the eccentricity. Okay, so now let's move on. Okay, so let's go over this problem. So problem number 1 says, determine the eccentricity of the ellipse given by x minus 6 quantity square divided by 100 plus y plus 1 quantity square divided by 9 equals 1. So here I need to know what c is. I know that a is the biggest number, which is this one, and so this is a squared, and then this is b squared. The 9 is b squared. So if I use the formula that was given, which is c squared is a squared minus b squared, so c is basically the square root of 100 minus 9, which is the square root of 91. And that is approximately, then put that in the calculator. So the square root of 91 is 9.53 and 9. So get at least like thousands places here. So that's your c. So for the eccentricity, which is c divided by what letter? A. So c is 9.539 divided by a, and a is 10 because this is a squared. So when you get the square root of that, so a is 10, and that gives you divided by 10, and that gives you 0.954 when you round it up. So this is the eccentricity for that problem. Okay, so which means that it's going to be almost touching the 10, so it's very elongated, okay, on the x-axis, which is like that. Any questions about number 1?
Was it
No?
10 or the 1?
It was 10 on the this right here.
I mean, the square root?
The square root of 100 is 10, so you're going to be moving from the 6, 10 to the right, and then 10 to the left.
Oh, okay.
So the eccentricity means that, it would be The C, it's almost touching the A.
Because it's, okay, so once it gets, when it becomes a whole number, that's when it's already touching.
When it's a whole number, a 1, if you have the eccentricity A equals to the B, that's just a circle. Yes. Okay. Okay, so let me give you one so you can work on that. So try number 2. Number 2. Okay, determine the eccentricity. Let me give you.
We put eccentricity.
Find the eccentricity of that problem. So first of all, you need to find the C, and the C is just the square root of 40 minus 12, which is 28. So the square root of 28 is 5.2892. Then the A, well, the A square is 40. So when you get the square root of that, that gives you 6.325. Then just divide those two numbers, and the eccentricity would be 0.837. That's it. So any questions about eccentricity? Okay, this is the first part.